Okay, so yeah, I'm going to be talking today about, in very general terms, about generative AI, and I thought it might be. Uh, I continue to be amazed at what Gen AI models can produce, and their potentials to assist us with our work. So I thought I would start with some quick real-time examples from ChatGPT 4. These aren't the prompts that I used when I was preparing these talks, but I could have. So I might say, give me 5 ideas for a talk about generative AI for systems librarians in academic libraries. And it handles that prompt pretty well. Um, these are more specific than my talk, but then the next thing I could do, let's say, is I don't like looking at them in that way. I can say transform these into a table, and it handles that task really well as well. I can even say write a Python script that randomly selects one of these ideas. And no problem doing that. And then this is just for fun. Write a 200-word introduction to topic one in the style of the King James Bible. Lo, in the days of great knowledge and wondrous advancement, there arose a tool mighty in its workings and subtle in its craft called generative AI. So I'm going to stop ChatGPT and open up my deck. Okay, so yeah, experimenting with Gen AI models like ChatGPT can be useful and interesting, even astonishing, but it doesn't tell us how they work or how best to prompt them to produce useful results. And that's what I'm going to be talking about today. So I'm pretty new to this topic, so I'm going to be drawing pretty heavily on a couple of sources that I recommend if you're new to the topic as well. One is AI in Writing by Sydney Dobrin, and the other is Teaching with AI by Bowen and Watson. And then also, I had a collaborator, ChatGPT 4. I wanted to kind of get experience using it more while developing this talk. So, some of the kinds of things that I asked it to do. What do you think of the following definition I've come up with for generative AI? Is the phrase using algorithms redundant? And it was. And it provided me with good reasons for why that was. And so I got rid of it and it revised my definition. Give me 5 examples of algorithmic prejudice, bias in the selection of data that an AI has access to in generative AI. So here I'm providing it with some context by providing it with the definition of that I've come up with for that particular term. Convert this citation to APA style. Give me a chart of the big 6 large language models, and I told it then what columns I wanted, and it produced that. And I didn't use it verbatim, but it did give me a head start on a chart that I'll use as one of my slides. What do you think so far? It's not done of my notes for a presentation on generative AI. Tell me some strengths and some ways to improve it. And then I fed it all of the slides I had developed at that time in my notes, and it made some suggestions based on that. And I think those are all probably examples of ways we could, depending on our institution's policies and the policies of an instructor, say like endorse a student using something like ChatGPT 4 without sort of doing the dreaded, write me a 5-page paper about X, right? So I came up with my definition for generative AI. Generative AI is a kind of machine learning that creates new content based on patterns it's identified on data it's been trained on. Unlike traditional or predictive AI systems that are primarily designed to classify or analyze data, generative AI focuses on producing original outputs that mimic the data it's learned on. So using generative AI is pretty much works the way that I've demonstrated with ChatGPT. You provide the AI with a prompt asking for an output. The AI then scrubs through all the available data that it has looking for patterns. It reorganizes that data into a pattern to answer the prompt, and it learns from each encounter it has with a user. So some examples of, so what does generative AI generate? Well, some examples of generative AI content are human-like text, transcripts, computer code, images, music compositions, videos, 3D models, and scientific simulations. So I started my definition with the phrase a kind of machine learning. So to dive into that a little bit, machine learning is a subfield of artificial intelligence in which computers use algorithms to perform tasks and improve at performing those tasks without being explicitly programmed with very specific step-by-step instructions. And because it's the most common form of AI, it's sometimes used synonymously with the term AI. So, as we know in traditional programming, we use explicit sets of linear instructions to get the results we want. I might use an if-then structure, for example, to tell a web browser that if the user clicks or taps on this button, then reveal the main menu. Machine learning doesn't work in this linear way. Instead, this form of AI uses sets of rules or instructions that learn each time they're used to work on a task. They then make predictions and decisions about what the next action might be based on past experience in performing similar tasks. As Sidney Dobrin explains in his book AI in Writing, machine learning is how computer systems use algorithms to analyze and draw inferences from patterns they identify within specific data sets. When an AI recognizes patterns within a data set, it learns to make inferences about those patterns. And so that's what we mean by machine learning. Um, One thing that really expands what a machine learning model can do is a neural network. So in 2011, Google founded an AI research team known as Google Brain. They took advantage of the lower cost of computing and the availability of huge clusters of computers in giant data centers. They connected 16,000 computer processors into a single network with a structure that was inspired by the human brain. And I say inspired by the human brain because we have, some ideas about how the human brain works, but that's uh, it not nearly as sort of concrete or it's very speculative about how the human brain works ultimately. So these artificial, what they built was an artificial neural network. So a type of machine learning where nodes, individual computational units, are organized into layers that seek to emulate our current understanding of the human brain. These networks can look for patterns in massive data sets. Data is broken down into tiny components and processed by thousands of nodes. So in addition to having access to this massive processing power, Google also had a massive data set at its disposal, namely YouTube videos. So it turned its Google Brain loose on 10 million images found in YouTube videos looking for patterns. And what was the one of the first patterns it found? Well, you can probably guess our feline overlords. In the end, it found something like 20,000 patterns, only some of which were cat related. So a neural network has to be trained, and a neural network needs some way to recognize patterns and take actions based on that. So there's two ways to train these networks. One is called supervised learning, and the other is unsupervised learning. In supervised learning, the input data is labeled, and the AI classifies new data based on how it's been trained. In unsupervised learning, the input data is not labeled, and the AI tries to discover patterns based on what it sees in the data. So, for example, an example of supervised learning might be spam email detection. The AI is given a task, identify whether an email is spam or not, and the training data would be a collection of emails, each labeled as spam or not spam. And the goal would be to learn to classify those emails correctly by identifying features commonly associated with spam in the subject line or the address or what have you. And an example of unsupervised learning would be, for example, feeding an AI just a big corpus of unlabeled documents and then asking it to identify topics that it finds in those documents that are unlabeled, and it has to sort of make up its own rules for discovering topics or themes within the text. So another sort of training part of the training technique for these neural networks is deep learning. And that makes use of multiple layers of the neural network to transform data. Simpler tasks are deeper in the network and combine to form output layers that are more complex. So an example of this is facial recognition, where the simpler task would be to recognize, what groups of pixels are faces. And then the more complicated task, match features to known faces. So most machine learning models are designed to do one thing, like filter spam or identify faces. Generative AI requires a more generalized kind of model called a foundation model. A foundation model is a large-scale general-purpose machine learning model built using deep neural networks trained on vast amounts of different kinds of data. These models are designed to learn broad patterns, allowing them to adapt to a wide variety of tasks with minimal or no fine-tuning. These models serve as the foundation on which more specific applications are built. They're characterized by their broad applicability, scalability, and ability to generalize across different domains. And then many of us are probably familiar with this term as well, large language model. This is a kind of foundation model specifically designed to process and generate human language. And it's the kind of model used by services such as ChatGPT. So, although there are other ways generative AI can work, such as diffusion models and autoregressive models, and there are lots of different kinds of things they can make, such as images and audio. For the rest of this talk, I'm going to focus pretty much on generative AIs built on large language models to analyze and produce human-like language. So, the most widely used large language model architecture for text generation, translation, summarization, and more is generative pre-trained transformer, GPT. So it's called generative because it generates new content, pre-trained because the network does both supervised and unsupervised learning, and transformer because it transforms one group of words into something different. And that training we mentioned, unsupervised and supervised learning, it's trained on an astronomical amount of books, articles, and web pages, and it uses unsupervised learning to cluster words that commonly appear together. And then it uses supervised learning to come up with a probability score about how the words are related and predict what word should come next. So right now there are six major publicly available LLMs. They've each been developed by a different company, have different strengths, weaknesses, and quirks, and are the basis or the foundation for a range of different applications. Some research tools, for example, use OpenAI's GPT to connect to Semantic Scholars database of 175 million papers to help with literature searches. Others connect to the internet to verify information. So you're probably familiar with ChatGPT and perhaps even all of these, but they do have, again, their quirks. So, for example, Pi, which is produced by Inflection AI, is known to be better at emotionally intelligent interactions and to sort of be chattier. Um, Claude, produced by Anthropic, its Claude AI Assist is a little bit faster than ChatGPT. It also has more guardrails than a lot of these other models, and so it's can be relied upon more for safe, ethical output. On the other end of that is something like Grok, which is produced by X, formerly Twitter, which has less guardrails and pulls real-time information from X and is known for being better at handling humor and sarcasm. So, one of the cautions we should be aware about when we're talking about these large language models and, for example, ChatGPT, as Walters and Wilder say, ChatGPT is fundamentally not an information processing tool, but a language processing tool. It mimics the text, not necessarily the substantive content found in its information base. So, one of the interesting metaphors for this is called the stochastic parrot. It's a metaphor for describing how LLMs generate plausible statements, yet don't understand the text that they produce. It was coined by the computational linguist Emily Bender in 2021. So Bender asks us to imagine a world where everyone has a parrot on their shoulder. Each of these parrots also has a telepathic connection to every other parrot in the world. They're constantly listening in on humans as we make small talk, deliver lectures, read aloud, argue, and so on. But they don't understand any of the languages that we speak. So let's say a few years into this parrotocracy, the parrot network has gathered so many examples of human conversation that they can predict what a human would say in a given situation. So you could ask a parrot a question like, "How are you doing today?" And it would respond with something like, "I'm fine. How about you?" However, the parrot doesn't know what it's saying. It might actually be hungry, thirsty, or cold, but it still responds with "I'm fine, how are you?" because that's most likely the, correct answer because it's the most statistically common response. What the parrot says in response to questions has nothing to do with meaning. Its response is determined entirely by data and probability. This metaphor can also help us get at a problem with generative AI text. Since it's simply generating responses based on the data it's been given without understanding or critical reflection, it can end up reproducing the same bias statements and perspectives that are embedded in the data it's been trained on. And this is a problem that's not just with generative AI. It's actually a big problem with traditional or predictive AI, and that's something that I've been interested in for a little while. That draws on the data it's trained on, and even when these sort of AI systems are designed to reduce human bias, they can actually act to amplify them. And just with a quick digression, I'll just mention some ways in which that can happen. So facial recognition software trained predominantly on white male faces has difficulty recognizing the faces of women and people of color. Predictive policing that tries to figure out where high arrest areas, where to send police to patrol and whatnot, can reinforce the over policing of communities of color. Hiring discrimination, in which a company's AI learns to favor male candidates, can happen by associating male dominated language and job histories with success. AI assisted decisions about home loans and neighborhood investments that don't take into account things like the history of redlining continue to disenfranchise Black Americans. Google's search algorithm has long contributed to the pornification and commodification of Black women online. And risk assessment algorithms used in the criminal justice system to collect data uh, that are actually turn out to be proxies for marginalized identities, then the algorithms unjustly assign some individuals higher risk based on identity categories. So, how this gets expressed in generative AI, there are two main varieties of algorithmic bias, and one's called algorithmic prejudice, and the other is semantic legacy bias. In algorithmic prejudice, bias is in the selection of the data that the AI has access to. Say an AI image generator may have been trained on data that overrepresented certain demographics, such as white men. It may also associate those images with certain professions reflecting existing biases in media. In semantic legacy bias, the prejudice is rooted in the language used to train the AI. Having been trained on language that shows gender bias, its output might reflect that, assigning male pronouns, for example, when referencing doctors, and female pronouns when referencing nurses. And then the outcomes of these kinds of varieties of algorithmic bias can be things like representational bias. If the AI's training data is unbalanced or unrepresentative, some groups may be underrepresented. Stereotypes. So Gen AI algorithm is looking for patterns in data, so they're likely to reproduce stereotypes within the data they've been trained on. This can be more of a concern with data sets that have large amounts of historical writing or drawn from things like social media. Contextual bias. Gen AI algorithms may produce homogenized views of people in society rather than reflecting nuanced complexities of different groups and how they communicate. And visual bias. Image creating algorithms may privilege certain skin tones, facial features, body shapes, or beauty standards. Then there is the problem of AI hallucination. The AI generates results that are incorrect, nonsensical, or fabricated and presents them as if they were plausible or true. And this is can be caused by insufficient data, unclear prompting, limited data in a large language model, data bias, or overly specialized data. So, in the second part of the talk, I want to talk a bit about prompt engineering. Whoops. So to try to provide something a little more practical than this kind of high 10,000 mile up discussion of what LLMs and generative AIs are. So prompt engineering is crafting ideal inputs in order to get the best results from generative AI and large language models in particular. And I think it's relevant to librarians in particular. Bridges, McElroy, and Wellhouse, in their article, Generative Artificial Intelligence, Eight Critical Questions for Libraries, suggest prompt engineering exists at the intersection of traditional library keyword searches and search engine optimization. It also requires a new syntax similar to natural language, but with enough quirks to be its own skill. Adapting existing lessons on keyword searches allows librarians to extend one of their traditional roles into an area of increased institutional interest. So when we're writing and revising prompts for generative AI, we want to make sure that they meet these criteria. They should be clear. We need to remember that an AI can't make assumptions and that they don't handle ambiguity well. Ambiguous prompts are more likely to cause hallucinations. They should be specific. Prompts must have enough information for the AI to act on. Vague prompts will result in weaker output. They should be contextual. Prompts with contextual details are more likely to produce strong output. So provide as much detail in your prompt as possible. This includes background information, intended audience, genre, tone, and style. Accurate. A Gen AI app can't tell the difference between correct and incorrect information in your prompt. So it will assume your prompt is true, and so a prompt with false information may produce false output. It may even become part of the large language model and impact future outputs from the program. And finally, ethical. Prompts should avoid directing AI towards offensive content, disinformation, and content that might lead to harm. It's also important to keep in mind the Gen AI programs, as I mentioned, often have their own biases, and prompts should be written whenever possible with an awareness of those biases. So there are some different ways in which prompting methods in which you can give an AI prompt. The first is zero shot prompting. The prompt represents a new task with no prior examples. Few shot prompting. The user provides the AI with a few examples to guide it before giving it the actual prompt. This helps the AI to understand the context. I've seen this done. I watched someone do this where they basically started providing a set of question and answers for a chatbot they were training, and they provided a sort of factual question and a factual answer, factual question, factual answer, and then also indicated they provided a nonsense question and then an answer that said unknown. And it provided another nonsense question, provided the answer unknown. So kind of providing some context for how the AI is expected to respond to certain kinds of input, provided it with greater context in training it. And then chain of thought prompting, the user guides the AI step by step through a logical progression or sequence. This is especially useful for complex queries where the answer requires a series of steps. So some tips about prompting LLMs. Um, so break down your task into smaller and smaller components. So if I was looking for help on writing a paper on generative AI, I might develop one prompt for idea generation, another for outlining, another for drafting an introduction or conclusion. Provide context and boundaries. Try to provide the AI with information about the audience, the genre, the intent. If you're asking the AI for help developing an assignment, for example, you might give it information about your students, your learning objectives, your pedagogical style as part of the prompt. Interact and provide feedback to the AI. Don't expect a single prompt to be enough. Act as if you're having a dialogue with the AI across multiple prompts. Get help from the AI itself for prompting. So I might prompt the AI with something like, I'm trying to develop a talk about generative AI for a group of systems librarians. What information do you need to suggest some relevant topics? Or I might say, I want to develop a hands-on activity about prompt engineering. Can you frame a prompt to help me with that? And this kind of blew my mind. This is from Bowen and Watson. You can add language to your prompt like slow down and think more carefully about X, and it will generally produce better results. So you can literally ask, I'm not sure what mechanically is happening behind the scenes, but if you do that as part of initial prompt or as part of a follow-up instruction, you're actually liable to get better results. You can ask the AI to work in stages. You might say, work on this problem step by step. Or you might say, before you begin, ask me what other information you might need to fulfill this task. You might say, don't do anything yet when you start the prompt. First, ask me if any part of what I'm asking you to do is confusing. And then Bowen and Watson have some other sort of more specific suggestions um, about specifying task, format, voice, and context. So in terms of specifying the task, one of the complaints that people sometimes have with generative AI is that it produces sort of bland or generic content. They suggest that in specifying, in sort of using more specific language to indicate exactly what you want the AI to do, you might be more satisfied with the results. So summarize, elaborate, reimagine, clarify, synthesize, abridge, just kind of paying attention to the verbs that you're using when you're prompting it. You can specify format. It's part of, again, giving it context, letting it know that you're writing a blog post, an email, that you want a spreadsheet, that you want a graph, that you want that you're working on a syllabus. So letting it know what the format is. Specifying voice. So what kind of style of language do you want? So you could say using academic, marketing, comic, or medical language. Do you give me produce a document about X, or as I did in the style of the King James Bible, or perhaps SOU Southern Exposure, or a choice book review. You know, give me an analysis of X. You can say write this like a and a kind of person. So write this like a copywriter, or respond like a copywriter, a computer scientist, an academic librarian, a real estate agent. You could even say in the style of my professor, or in my style if you have published work online, or you can feed it. So in the style of my professor, if I've never done anything like it, but if I wanted to, what I would do is I would go out and grab a bunch of articles written by that person and then attach them as part of my prompt, and ask it to fulfill the next part of the prompt based on all of that input. And you could do that for yourself. The closest I've come to doing something like this, I gave it a couple of letters of recommendation I had written for students in the past. And then I had a student who was seeking a letter of recommendation to the MFA program at the Iowa Writers Workshop. And again, as an experiment, um, I gave it samples, the writing samples for the student, their poetry, and their statement of purpose, and some information about Iowa and the program, and its admissions, and it came up with something that was kind of shockingly good. I started a new draft. I didn't sort of just paste that into a document, but I did consult it as a way to think about how to draft a document like that. You could ask it to respond as if you were Yoda, Martin Luther King Jr., single, married, happy, sad. You can include tone modifiers, like write this as if in a way that is serious and empathetic, or casual and funny, or positive and enthusiastic. And finally, specify context. What further context or examples can you provide? You can say, use, read, follow these examples. Make this suitable as a reading assignment for an undergraduate course. Indicate I'm trying to be serious and funny at the same time. I want a range of solutions that are inexpensive or accurate or fanciful. Only do this if that happens. Wait until I respond. So just to wrap up, it's such a huge topic. I really was just trying to get at, what is Gen AI, how does it work, and some tips for prompting it. I think that we're going to, continue to encounter it more and more in libraries. It's going to be and is integrated into our software and systems. And we're going to have responsibility to evaluate what our users need. Do they actually need this kind of research assistant? And do we sort of turn it on or not? Um, we librarians have always dealt with questions of ethics, copyright, and fair use. And again, it's likely that we're going to struggle with those in relationship to generative AI, and be asked to consult with faculty about that. In teaching our information literacy classes, we're going to think about algorithmic and AI literacy as a part of that. Um, we're likely going to be in a position to be advising faculty about selecting AI tools to do the kind of work that they do, uh, evaluating AI tools that are designed specifically to do academic research. Prompt engineering, I mean, I can imagine helping students the way that we help students, one-on-one with search strategies, also, helping them with prompt engineering as we walk them through a writing process that includes things like pre-writing and brainstorming and things like that. Maybe that might be the appropriate time to use something like ChatGPT. Faculty may want us to help them detect AI use, which, as I'm sure you know, is really a difficult thing to do, or leads to a lot of false positives, and so it can be really hazardous to do. Automating metadata and cataloging, building chatbots for common questions. Like I've thought about whether or not it might make sense to build a chatbot to replace our FAQ that we have on our website about library policies and things like that. But that would be quite a ways down the road for us. But yeah, so that's what I've prepared as a kind of broad overview of Gen AI. Thanks for giving me the opportunity to share it with you.